Welcome back to Section 2 of Unit 1. Let's talk about a brief history of geology. Where did it all start? Well, I guess technically we can go back to the 4th century BCE of the ancient Greeks. Aristotle, that's this guy right here, he made critical observations of the slow rate of geological change. What he said was, the Earth changes at a very slow rate, and that these changes cannot be observed during one person's lifetime. Now, this was almost 2,500 years ago. That's a big statement. The Earth is changing, but you can't see it. You gotta imagine how the people would have laughed at that. So yeah, the Earth's changing. It's so slow, but it's so slow you can't even see it. They didn't really have instruments to kind of prove these things, but a great idea by Aristotle. Fast forward almost 1,500 years to the 10th century in the Middle Ages to China. A gentleman by the name of Shen Kuo identified gradual climate change after his observations of ancient petrified bamboo found in a preserved state underground. As they were digging through the mud, they found these petrified bamboos, and kind of would help illustrate different climates must have been in this area. Therefore, climates must have changed. So using Earth's materials to identify climate change, all the way back over 1,000 years ago. Again, fast forward to the 17th century, that's the 1600s, in the Netherlands, in Europe, a very famous name in geology, Nicholas Steno, one of the founders of modern geology, he stated that the Earth's strata can be defined as horizontal layers of rock having approximately the same composition throughout. So he said kind of Earth's layers are kind of built one on top of another. And if you want to get to older Earth, you dig down. You want to get to younger Earth, you look at the stuff closer to the surface. 100 years later, 18th century, 1700s, in Germany, Immanuel Kant, one of the first to really question the age of the Earth. Up until this point, very biblical idea about how old the Earth was in a matter of thousands of years. This just question about the Earth represented a big turning point in the study of the Earth. So again, kind of the first to say, I don't know, I think the Earth's a little bit older than maybe just a few thousand years. Same century in Scotland, James Hutton discussed an idea called uniformitarianism, which we'll talk about a little bit later in this unit lecture. Uniformitarianism, a very fundamental principle in geology. It almost sounds common sense, but it states that the processes of geology occurring now also occurred in the distant past. Volcanoes happen now, they must have happened in the past. Earthquakes happen now, earthquakes must have happened in the past. So, climate's change now, climate change must have happened in the past, but what's going on now is kind of help being driven by humans. So, a little bit bad example, but in any case, stuff going on now must have happened in the past. So, what we can figure about the past, we can actually analyze what we have now. So, kind of cool. So that kind of, I don't know, seems like common sense, but someone has to say it in order for it to kind of be thought about and agreed upon. 19th century, 1800s in England, my main man, Will Smith. Oh wait, sorry. Oh, this one. William Smith, my fault. So William Smith was in England, and he found that fossils were a highly effective means of distinguishing between similar layers of rock. And Nicholas Steno talked about layers of earth and layers of rock, older stuff on the bottom, younger stuff on top. So William Smith said, well, looking at these fossils, we can tell that these fossils are very old, so these rocks are older, these fossils are younger, these rocks are younger. So by using fossils and different types of rocks, he was able to create the first large-scale, what's called a geological map. It's a map that doesn't necessarily show roadways and things like that, but it's a map that shows the geology of an area at the surface or near the surface. Also in the 19th century, in Scotland, William Thomson, the first Baron of Kelvin, if you're familiar with chemistry and the Kelvin degree scale, that's this guy, he published calculations that fixed the age of the Earth, going back to that age of the Earth stuff, at between 20 million and 400 million years. This is based on physics and cooling rates and how big the Earth is, and then calculating, well, if the Earth is this big, and it started off this hot bowl of mess, this hot molten ball, how long would something that big take to cool? And so based on what he thought the Earth was made out of, which we didn't know at this time, he said it'd take about 20 million to 400 million years. Now, That's still pretty far off of 4.56 billion years, but still, he's putting the number based on some sort of data in the millions of years as opposed to just the thousands of years. 20th century, so 1900s in Germany. That's handsome devil right here. His name is Alfred Wegener. He proposed the idea of continental drift. This notion suggests that the shapes of continents and matching coastline geology between some continents indicates they were joined together in the past. They're not now, so the continents must drift around. So he kind of opened up a book of maps, noticed the outlines of some continents, and cut them out and kind of push them together. And he kind of noticed that the continents kind of fit together, in some places kind of fit together like a puzzle piece. Later evidence matching up geology and other information proved he was actually right, but just based on opening a book and looking up some maps, he came up with this notion of continental drift. So, very powerful notion that helped to get us to the theory of plate tectonics. Remember, theory, highest level of knowing. We're going to go ahead and pause right there. Again, that's just a very brief summary of some of the more famous names in geology and how we got to where we got to today. Okay, not all of that important, but just wanted to get some of those names out there. So what we're going to do, we're going to pause right there. And when we come back, we're going to start focusing on the Earth and figure out the Earth's place in the solar system. So now we're going to get into this idea of Earth being created, its forming, where it's located, etc., etc. I'll see you back here in just a minute.